Okay, so it's got this diagram. I'm going to add to the diagram. Uniform rod, so centre of gravity, centre of mass will be right in the middle. That's 25 newtons going straight down there. Length 1.6. Rest on vertical plane. Ending contact, rough horizontal ground. So I'll have a normal contact force up here. I'll call that RB for the base, or I've actually got RA for the A here. And it's obviously got friction coming in here because it wants to slide outwards. It's resting here. It's a smooth wall, so I have a normal contact force, normal contact to the wall. I'll call here. I'm going to call that R. I could call it RB, but that's what I'm going to want to find. I'm just going to leave it as R. And 60 degrees. I think that's pretty much where we are. And calculate I want to calculate this R here. So it could be moments. It could be resolving. If I resolve, I've got lots of these forces here. If I take moments about A, then F and RA both go through A, so I won't get those. So I want to take moments about A, and I'm going to get the anti-clockwise moments equals the clockwise moments. And as always, if I can't work, don't think I can put the length on here. The length of the rod is the whole length from there to the end there is 1.6 meters, so it'll be 0.8 meters. This bit here will be 0.8 meters. So the whole distance is 1.6. If I can't work out what this distance is going to the perpendicular there, then what I can do is I can split this force up. I can split this up into a horizontal force going straight across and a vertical force going up there. You used to draw it here, but we draw it there now. Angle, that's 60, that's 80 there. That'll be 80. That's a right angle there. So this angle here will be 10 degrees. So that'll be 10 degrees in that bit there. And now I can work out what the various forces are. So anti-clockwise moments are, I've got this bit here, this pink bit here, which is going to be R cos 10. That will be R cos 10. I've got to times it by the distance away from here, so it's going to be times by 1.6, and this is 60 here, so I'm going to want that distance there in effect, so it'll be 1.6 sine 60. That's going around anti-clockwise. That's good. This one here also, that component there is also going to be going anti-clockwise. I'll spin it up there, so it'll be the same thing. So I need to add on whatever that is, and that will be R. And instead of being R cos 10, it'll be the same as this bit here, which will be R sine 10. And that will be times by the distance. The distance I'm looking at, that will dot all the way back to here. So it'll be this distance here, which is 1.6 cos 60. So times 1.6 cos 60, and that equals the clockwise moments, which is the force 25 times by the distance, and that will be, hypotenuse is 0.8, so it'll be 0.8, and it will be this distance here I need, so it'll be cos 60. And if I work that out, that gives me R times by this bit plus this bit, so I can factorise it. That gives me R times 1.503508, and that equals, work out the right bit, 10, and that gives me R equals 10 over 1.5035, and that gets R equals 6.65111, which equals 6.65 newtons to 3 significant figures. And that's how I done it. Of course, if you could have worked out a distance, you could have done it actually a whole lot quicker. So I'll just do a diagram again, and then we'll have a go at that. Once again, I'll put the forces in there. So that'll be 25. That'll be RA. That'll be F. And this time here, I'm going to put R nice and long up here. Okay, and what I do know, I can work out some angles. That's 80, I'll do this in red. That's 80, so that's 100. 60, 100, 160. So this angle is 20. This is at right angles to there, so that's 20. So that angle there is 70. So this time if I do the moments, if I take moments about A, anti-clockwise equals clockwise. Clockwise moments is exactly the same as it used to be, which is 10. I just have to work out the anti-clockwise moments. So it's the force times by the distance, and the distance I'm looking at is this distance coming back here, where that's the right angles. We know that length is 1.6, so we times by 1.6, and it will be, this bit here will be sine 70. And then that will give you that R equals 6.65. So sometimes, although it may have looked difficult to work out that distance, sometimes it can be quite easy. You don't have to split the forces up into two components. And that's question 3 done.